Hello. This video is what I think about geology. I'm going to go ahead and say that geology is arse backwards, just like all the other sciences. Because, indigenous societies say that the earth is alive, right? Well, people say, what's alive? If something's alive, it has to eat and shit, right? It got to eat and poop. If you can do that, you're alive. If you can't do that, you're not alive. So, and now if indigenous societies and New Agers and the aliens and the spirits and me say that the earth is alive, well, then the earth's going to have to eat and poop. And I see the earth does eat and poop. And I'll explain why. It's called the growing earth theory. The earth grows. Rocks grow. You know plant's alive because it grows out of the earth from the energy from the sun. And I say earths grow. The earth grows from the energy of the sun. I have tried to bring this idea up to scientists, but they don't really, they kind of look at you fuzzy-eyed, so it's kind of like, and then they change the subject, so I guess they don't really understand it, they're not into it yet. But basically, to describe the growing earth theory, the theory is that the earth is growing in size. The idea is that all planets grow in size. What happens is the sun light shines down into the earth, super high frequency light, goes through the earth, to the middle of the earth, to the iron core, and feeds that iron core, and it grows. Rocks grow from sunlight just like plants, because it's alive, and its poop is oil. So oil does not come from dead dinosaurs and plants. It comes from the byproduct of the sunlight growing the earth to a larger size. Now, reasons people believe this is there's this. I'm inspired by this by oh my god, I can't remember the guy's name. A comic book writer. He interviewed on Coast to Coast, and if you type the growing earth, you're gonna see plenty of videos about it. And the idea is that during the dinosaurs, the earth was actually only 1/4 the size it is now. If you were to take away all of the oceans and patch all of the continents and islands and stuff together, they would fit together perfectly. Everybody knows that South America and Africa fit together like a puzzle. What people do not know is that Asia and the western side of South America and Australia fit together like a puzzle as well. So how did Pangea come apart like that? Some people say plate tectonics. Well, plate tectonics is great, but everything's coming apart. It's not just the Pacific that's getting lighter. It's the Atlantic that's getting lighter. It's the Pacific that's getting lighter as well. And so the idea is that back in the times of the dinosaurs, there was no ocean. It was just land. We had water, but there was no ocean. And we, over time, accrued water through meteors. Everybody knows most meteors are mostly water. Everybody knows that water is the most abundant material in the universe. It's hydrogen. Hydrogen is the most abundant material in the universe. Throw hydrogen and oxygen, which is also one of the most abundant materials in the universe, together, and you have water. Water's all over the place. So over the years, we just accrue water, and we're always accruing water. If you look at satellite photos, if you ask anybody at NASA, all the comets that come down, those things are showering us with water, and our water is increasing day by day. Now, if you look at the anatomics of the animals that lived that long ago, when Pangea was around, because it all congrues, it all fits together. 65 million years ago, we had Pangea, or however many million years ago it was, and the same amount of million years ago, this is when we had these dinosaurs. Now, we had dinosaurs, say the Brontosaurus. It's basically kind of like an elephant with really long neck and tail. So how come the Brontosaurus wasn't the same size as the elephant is? And how come the elephants of today aren't the same size as the Brontosaurus was? They're much larger. I think they're like 4 times larger. So how could they be so big? How could fireflies be 4 feet long? How could plants be much bigger? How could beetles be of gigantic size? Everything was huge back then. And the idea is that there was 1/4 the amount of gravity on the Earth, which allowed them to be 4 times larger. If you look at the Tyrannosaurus Rex, the idea is it's basically a chicken. Now, there could be no chicken that big with a head that weighs as much as a Volkswagen Bug running around these days. If we were to take the DNA of a Tyrannosaurus Rex and grow him to the size that he was, I think, 30 feet tall or something like this, his head would snap off. He could not hold his head up. And also those little velociraptors, those things were huge too, and they could run. They're designed to run like 60 miles an hour. But things that size cannot run that fast in the gravity that we have now. And so those are 2 points that fit together, Pangea and then the dinosaurs. There's another one, oil. The idea that oil is a byproduct of the Earth. Now, I guess, common knowledge now is that people say that oil comes from dinosaurs and plants. Well, if oil comes from dinosaurs, then why do we find oil in the ocean? There are huge oil deposits over the ocean floor that is no more than 40 million years old. So if dinosaurs died out 25 million years before the creation of this ocean floor, how did the dead dinosaurs get below the ocean floor? You know what I mean? The ocean floor was created out of magma, growing the continents apart. The Atlantic spews out, 10 centimeters a year? That's just a guess. So it's kind of like, anything from a dinosaur. If oil came from dinosaurs, the only place you should be able to find oil would be on land that existed when the dinosaurs existed, not land that was created after. Because oil can't migrate to the side. Gravity would pull the oil directly down. So there's 3 points right there for the growing Earth. Now the idea is that every planet grows. So not just the Earth. And then that's why the Earth is alive. You can say the Earth is alive because it eats and it poops. So I believe it. So what do you think? I think that's about all I have to say. Goodbye.